Thanks to the previous video, you're well aware of what the boxes on the periodic table tell us. Thanks to the previous video, you're well aware of what the boxes on the periodic table display. You know that each box displays the element symbol, the element name, the atomic number of that element, which tells us how many protons there are in a particular atom, keeping in mind that the number of protons identifies an atom. Each box also contains the atomic mass in decimal form. Keep in mind that the atomic mass is the combined mass of the protons and neutrons of a given element's atoms. Now, the periodic table is structured with rows and columns. The rows, which are horizontal, are called periods. And the period number or row number is tied to the principal energy level, also called a shell, where electrons reside. For example, all elements in period 1 or simply row 1 have one energy level or shell where their electrons reside. FYI, each energy level holds a certain number of electrons, and it is actually further broken down into subshells and orbitals, which is its own topic that I cover briefly in another video right here on the Subject Basics channel. But let's get back to what's pertinent right now. Now that we've addressed the rows or periods as they're called, let's address the columns, which are vertical and are called groups. Remember that guy Dmitri Mendeleev that we talked about in a previous video? You know, the guy who created the periodic table. Well, fortunately, he arranged the periodic table so that elements with the most similar properties were placed in the same group. The elements in each group or column have the same number of electrons in their outermost shell. Electrons in the outermost shell are called valence electrons, and depending on certain conditions, the valence electrons of one atom can participate in the formation of a chemical bond with another atom's valence electrons through the sharing as well as exchanging of electrons. Given that I've mentioned that each element has the same number of valence electrons as the group or column that it falls into, you may see that the periodic table displays an AB designation as far as labeling the columns, where the main groups of elements are labeled as 1A through 8A. And you see the main groups outlined here in this video. They're outlined in red. And the transition metals are often labeled as 1B through 8B. And the transition metals are right in the center. Now you may also see a periodic table where the columns are numbered sequentially, 1 through 18. However, even in this case, the valence electron count of the main group elements, the ones outlined in red, remains the same, with the range of valence electrons falling between 1 and 8. Now we'll start right at the top at our left, which brings us to hydrogen. Now hydrogen is a very special element on the periodic table, given that technically it doesn't really belong to a group. And when I say that, I mean that the only thing hydrogen has in common with other group 1 elements, which are called alkaline metals, is that hydrogen has one electron in its outermost shell, and that is the only reason why it's located in the column group 1. Hydrogen is actually a non-metallic, odorless, tasteless, colorless, and highly combustible gas. Hydrogen is also one of 7 elements that form what's called a diatomic molecule. And a diatomic molecule is basically composed of 2 atoms of the same element. Now these diatomic molecules generally exist because the element is so reactive that it needs to bond to another one of its atoms. H2 is hydrogen as a diatomic molecule, and it forms when 2 hydrogen atoms bond together and become a hydrogen molecule. And remember that a molecule is a group of 2 or more atoms held together by chemical bonds. Hydrogen is also considered the simplest, given that it's composed of one proton in the nucleus and it is orbited by a single electron. Now let's address group 1 excluding hydrogen. Group 1 is referred to as the alkaline metals, and they include lithium, sodium, potassium, rubidium, cesium, and francium. The elements in this group are solid in terms of their state of matter. You know the states of matter: solid, liquid, or gas. However, the elements rubidium, cesium, and francium are sometimes referred to as liquids because at just a bit past room temperature, they become liquid. And just an FYI, typically in chemistry, room temperature is referred to as 295 kelvins, which converts to 20 degrees Celsius, which converts to 68 degrees Fahrenheit. The elements that compose the alkaline metals in group 1 are very reactive. Why is that? Well, they all have one electron in their outer shell, and that's one electron away from being a full shell. As a result, these elements want to bond with other elements and lose that one electron. An increased desire of an element to bond means that the element is going to be more reactive. And again, all elements in group 1 have one valence electron. Group 2, referred to as the alkaline earth metals. These elements include beryllium, magnesium, calcium, strontium, barium, and radium. The elements in this group are solid and metal and are very good conductors of electricity. The atoms of this group are considered reactive and have two valence electrons. Group 3 is called the boron family and consists of elements boron, aluminum, gallium, indium, and thallium. Now, boron is a solid and a metalloid is a type of chemical element which has properties in between or that are a mixture of metals and nonmetals. Aluminum is a metal and it is solid. Gallium is a metal, but it is liquid. Indium is a metal and it is solid. And thallium is also a solid. The atoms of elements in group 3 have 3 valence electrons. And just a quick side note, if we wanted to be as simplistic as possible, we could say that each element could be classified as a metal or a nonmetal. However, this is chemistry, so we are intentionally diving deeper. The commonly divided categories that elements fall into are alkaline metals, alkaline earth metals, transition metals, metalloids, nonmetals, halogens, and noble gases. Group 4, the carbon family. The carbon family contains the elements carbon, silicon, germanium, tin, lead, and flerovium. Now, carbon is a nonmetal. Silicon and germanium are metalloids and solid at room temperature, and tin and lead are metals that are solid at room temperature. Flerovium is actually a radioactive synthetic element that is classified as a metal. Now, atoms that are in group 4 have 4 valence electrons. And you heard me mention that flerovium is a synthetic element. Well, these are chemical elements that do not occur naturally on Earth. These are elements created via lab experiments. And you won't hear me mention these much again. They're not really the focus of any type of basic or general chemistry introduction. Group 5, the nitrogen family. Elements in this group are nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen and phosphorus are nonmetals, and at room temperature, nitrogen is a gas, and phosphorus is a waxy solid. Arsenic and antimony are metalloids and are solid. Bismuth is a metal and is solid. Did you know that 2 of the elements, nitrogen and phosphorus, are actually essential for life? Nitrogen is also another one of the 7 elements that exist as a diatomic molecule. Elements in group 5 have 5 valence electrons. Group 6, the oxygen family. Elements in this group are oxygen, sulfur, selenium, tellurium, and polonium. Now, oxygen is non-metal and it's a gas. Tellurium and polonium are metalloids that are solid at room temperature. Sulfur and selenium are solid and are nonmetals. And oxygen, found in this group, is another one of the 7 elements that are found in nature as a diatomic molecule. Each element in group 6 has 6 valence electrons. Group 7 is referred to as the halogens. The halogens include fluorine, chlorine, bromine, iodine, and astatine. Elements in this group are highly reactive and can gain an electron through reaction with other elements. Elements in group 7 have 7 valence electrons. Now, you heard me refer to elements in group 7, the halogens, as the most reactive nonmetals. So if they're nonmetals, what are they? Well, fluorine and chlorine are gases, bromine is a liquid, and iodine and astatine are a solid. Again, all elements of group 7 have 7 valence electrons. Now, with the exception of astatine, all of the other elements in group 7 exist in nature as diatomic molecules. Group 8, the noble gases. Now, the first thing you may notice is that they're called noble gases. Well, at room temperature, all of the elements in this group are in a gas state. And these elements are helium, neon, argon, krypton, xenon, and radon. These elements are odorless, colorless, and are the least reactive of all the chemical elements. All members of this group have 8 valence electrons. And in fact, group 8 elements, the noble gases, are the most stable due to having the maximum number of valence electrons that their outer shell can hold. In this case, that's 8. Great, we covered the basics in tackling rows and columns, or groups and periods as they're called. But be sure to check out the other subject basics videos that tackle other basic areas of chemistry.